In today's lab, we're looking at glacial processes and glacial geomorphology. So what is a glacier? Well, a glacier is a mass of ice that originates on land and moves slowly downslope under the influence of gravity. The way glaciers form is through the accumulation and compaction of snow. In essence, what has to happen to make a glacier is this. Snow falls during the winter, let's say. And then when summer rolls around, some of that snow that fell during the winter has to make it through the summer. So in other words, some of the winter snow is still on the ground at the end of summer. Then when the following winter arrives, more snow falls on top of that. And when summer comes around again, some of that snow that fell in that preceding winter has to remain on the ground. And then you just continue this cycle for a long period of time. And what begins to happen is the snow on the top compresses the snow down below, which then causes that snow down below to meld together into solid ice. Once you build that ice up, let's say 60, 80, 100 feet, it will then, depending on the slope, begin to flow, a little bit like pancake batter flows. But notice climatologically what has to happen. I'm not talking about winter temperatures. I'm talking about summer temperatures. Summer temperatures have to remain low enough so that some of the snow from the preceding winter is able to remain on the ground, and then that has to remain that way, those kinds of climatological conditions, for a long enough period of time to build up glacial ice. Historically on this planet, there have been swings in temperature and climate that may go on for hundreds of years, thousands, tens of thousands, hundreds of thousands, even millions of years, when temperatures will go up 2, 4, 6, 8 degrees Celsius or go down 2, 4, 6, 8 degrees Celsius. And this can cause radical climatic swings on our planet. The last time temperatures were cold enough for a long period of time to allow massive buildup of glacial ice was during what's known as the Pleistocene epoch. That was from about 2.6 million years ago to about 10,000 years ago. Beginning maybe about 25,000 years ago or so, global temperatures began to warm up. And 10,000 years ago, we entered into what's commonly known as the Holocene epoch, which is kind of becoming the post-glacial epoch. Where are we now? Well, anytime the majority of glaciers on this planet advance, and we have a net increase in glacial ice on the surface of the planet, we enter into an ice age. And actually, since the end of the Pleistocene epoch, we have had multiple ice ages. Anytime the majority of glaciers on the planet are receding and there's a net decrease in glacial ice, we enter into what's known as an interglacial or interglacial period. This is what we're in now. We are, of course, losing glacial ice. Just to handle a technical term, the loss of glacial ice is known as ablation. So this is the loss of glacial ice through melt, evaporation, and sublimation. During the Pleistocene, about 30% of the land area of our planet was covered in glacial ice. Today, we are about 10% of the land area being covered in glacial ice, which is overwhelmingly in two places, of course, Greenland and Antarctica. If you can imagine, in order to have 30% of the land area covered with glacial ice, that would have required a lot of water. That water came as a result of storms out of the global ocean, which means that during the greatest glacial advances, let's say sometime between 2.6 million and 10,000 years ago, but maybe right around 50,000 years ago or so, sea level on this planet would have been 400 to 500 feet lower than it is today. That would have allowed the river systems to cut 400 to 500 feet deeper into the land. As sea level has risen, as the glaciers have melted over the last 30 or so thousand years, sea level has then filled in many of these landforms that were created by that running water. Chesapeake Bay is a great example of that. If you look at Chesapeake Bay, you can see on the right-hand side there, it looks like a dendritic stream pattern because indeed at one point it was a dendritic canyon, but sea level has risen and it's begun to fill in. What would happen if we melted all the glacial ice? So every bit of it, all of Antarctica, all of Greenland, all the other glaciers on the planet? Well, sea level would rise by about 200 feet, and you can see what that would do to California. On the left-hand side, you can see that the coastal area of California would basically be inundated, and it would even go into the Central Valley and fill in a large portion of the Central Valley. That's the Sacramento Valley and the San Joaquin Valley of California. If you look at the right-hand side, you can see the way California looks today. Then compare that to the left-hand side, no glaciers, and what would happen with the California coastline.